Dr. Ashrafian. Good morning, Dr. Kayaçetin. Hello, dear audiences. Welcome to our session of Zero Energy Buildings for Everyone. First, let me introduce myself. I am Fulya Özgül Koçak, CEO of Onduline Avrasya. I graduated from Marmara University, Department of Business Administration in English. I started my career as an auditor in PwC and joined Onduline in 2000. Since then, I work for Onduline in various departments. And in 2018, I became the general manager of Onduline Turkey. And since 2019, I am leading the zone of Africa, Central Asia, Caucasus, Middle East, and finally Turkey again. I kindly remind our audiences that which prefer to listen to this in Turkish is that a simultaneous Turkish translation is available in broadcast number 2. And one more note is that you can reach LinkedIn profiles of all speakers and moderators from the detailed program at the forum webpage. You can post your questions to the speakers via LinkedIn that you cannot ask due to the time limit of this session. According to Paris Agreement, signed in 2016, all buildings must be net zero carbon by 2050. The initiative includes national and local policies to make new buildings 100% zero carbon by 2030 and existing buildings by 2050. This is an aggressive target. Buildings account for roughly 1/3 of global emissions, and the operation of the buildings alone accounts for 28% of energy related to carbon dioxide emissions. This makes them among the largest contributors to climate change. Improving buildings is also one of the most proven, cost-effective climate mitigation solutions available. During this session, we will look at this subject from a different angle. We will listen to Assist.Prof. Dr. Touraj Ashrafian and Dr. Nuri Cihan Kayaçetin on our topic, Zero Energy Buildings for Everyone. Assistant Professor Dr. Touraj Ashrafian will be our first speaker. Dr. Ashrafian has more than 17 years of work experience in architectural design and built environment science. He has graduated from Istanbul Technical University, Department of Building Science. Since 2016, he has been working as an assistant professor at Özyeğin University and leading architectural design, building physics courses in graduate and undergraduate level. He is founder and co-director of the Building Materials and Physics Laboratory of Faculty of Architecture and Design at Özyeğin University. He has published several journal articles and conference papers. He has responsibilities on some national and international projects, including EU-supported projects in the field of building energy efficiency. His areas of expertise are building energy efficiency, nearly zero energy buildings, cost-optimal analysis, life cycle analysis, climate change and building-related issues, occupant behavior and comfort, and existing buildings energy-efficient renovation. He is a member of the Society of Building Science Educators. He is a recognized reviewer in Energy and Buildings and Environment journals since 2011. Dr. Ashrafian, can you please start your presentation, please? Thank you.
Thank you very much, Fulya, for introducing me. Firstly, I would like to thank to the organization committee of the Zero Build 20 Forum for inviting me here and give me such a great opportunity to present my work and my opinions through this platform. Before starting my presentation, I would like to have a short introduction about this subject and emphasize on the subject and also explain why I have chosen this topic to present here. climate change is a real fact, and we can see the impact of the climate change on our life day by day. Hurricane thunderstorms, or animal extinction, or pour down and droughtness, famine. All of these are the impact of the climate change on our life, and we have to mitigate such impact on our life and on humanity. Buildings are responsible for huge energy consumption and also greenhouse gas emission in the world. They are accounted for about 40% of total energy consumption, and it is higher than any other sector like transportation sector or industry sector. And that's why it is very important to reduce the total energy consumption in the building sector through different measures like design and renovation of the building in under zero energy approach and so on. But there are lots of barriers and challenges in using such an approach. For example, social challenges or technical challenges, let's say financial challenges, legal challenges, and also scientific challenges. All of them can prevent us to reach to the proper result when we want to have when we want to apply such a approach in our building. So that's why it is important to emphasize on all of these barriers and all of these challenges to be able to overcome to them. I'm sure that it will take about more than 100% to solve all of these barriers, 100 years to solve all of these barriers. But if we wait up to 100 years later, again, we have to spend 100 years to overcome to do all of these barriers. That's why we have to start from today, and we have to try to solve these problems. In the social side, we have the awareness problem. In the technical side, we have know-how problems. In the financial side, we have the finance and economic problems. But we shouldn't wait to solve all of them. We should try to solve them. And it's all things that we have to know. And another things that is important to know is that when we design or renovate a building with zero energy or nearly zero energy approach, we have to consider the whole life cycle of the building. If we just focus on the operation stage and use the stage of the building, we may have adverse result, because to renovate a building in zero energy manner and with zero energy approach, we need to use extra material, we need to install extra system, and all of these systems require huge energy to produce. Not just the operation period, but pre-operation period of our building is very important, and we should emphasize on this stage in our studies and in our works. That's why I have decided to present a presentation with, let's say, life cycle challenge of zero energy building design and retrofit. I'm going to share my screen and start my presentation after this introduction. Okay, I hope that you can see my screen right now. Yeah, this is the content of my presentation. I will start with life cycle assessment, and then I will emphasize on the importance of the life cycle approach in zero energy building design and retrofit, and then I will make a categorization regarding the life cycle challenges of zero energy building design. And at the end of the presentation, I will have some recommendation and conclude my presentation. As you can see in this slide, we can divide the whole life cycle of a building to three main categories: manufacturing stage, operation stage, and end of the life stage are three main stages of building life cycle. All of these stages have the variety of steps. For example, the raw material extraction is the first step of the life cycle of a building. Then, after extraction from a mine, we need to transport that material to the factory, to the manufacturer factory, and then the process there will be started. And after that, we need to transport that material to the construction site. And all of these steps require to consume energy. And when we consume energy, we will have greenhouse gas emission at the same time. And when we transport that material to the construction site and then start to construct, also we consume energy. And then we start to operate our building. We start to use our building. And during this use, we may need some repair, some maintenance, some replacement. And again, we consume energy. When the life stage of the, or let's say use stage of the building is finished, we need to again demolish the building, transport the waste to the waste planet or waste processing site, and then dispose that material or recycle or upcycle that material. All of these steps again require energy consumption. But most of the time, we just think that our building is zero energy building, so it's consuming zero energy. It will not have any effect on the environment, but it's incorrect, because pre-stage or pre-operation stage also is accounted for a huge energy consumption. Also, there are different approach in life cycle assessment of the building. For example, one of these approaches is cradle to grave approach. Another one is cradle to cradle approach. But also there are other approaches that most of them are regarding manufacturing stage, like cradle to gate, cradle to site, cradle to handover, or cradle to end of the use. But the things that is important for us is cradle to grave or cradle to cradle approaches. In the cradle to grave approach, at the end of the building life, the material will be useless. And also they are not worthy to reuse it. So they go to the disposal site and it's finished. But in the cradle to cradle approach, we can reuse it. We can reuse the material, recycle the material, and even upuse the material and change the, let's say, object of the, change the, let's say, use place of the material. For example, when we can recycle the material and use it in a battery, or in a, let's say, in a car and so on. It's not necessary to use again in a building. These are two approaches that are very important for us. As you can see here in this slide, in the cradle to grave approach, we have a row starting from raw material extraction and end in the disposal. But in the cradle to cradle approach, we have a circle. It's starting again with raw material extraction and end with raw material processing, or again, let's say, extraction from the recycled materials. It's very important because in the cradle to cradle approach, we have lower impact on the environment, but in the cradle to grave approach, we have waste, and all of these waste cause to environmental problem, and cause to extra problem like, again, climate change and so on. So that's why I'm going to emphasize on the cradle-to-cradle approach. Again, here, according to the EN 15978 standard, we can divide the life cycle of a building to manufacturing, use, and demolition phase. According to different standards, different studies, the embodied energy, or let's say manufacturing energy of material, can be accounted for a huge amount of life cycle energy consumption of a building. Of course, the lifespan of the building is very important in this case. So, for example, in Johan's and Norton study, in which the lifespan of the building, or maybe the calculation period of that study, is considered as 25 years, the embodied energy share is a huge share of the life cycle energy consumption, as you can see here, and it's about 67%. But for example, in other studies that the lifespan of the building is high, as 60 years or 50 years, the total share of embodied energy consumption during the life cycle of a building is as low as 25% or 45%. And also you can see some lower percent as 2% or 10% or 9%. But generally, we can say that the embodied energy consumption of a building can be higher than 10 or 20%. And also, according to a study by Ramesh et al. That was conducted in 2010 and is published in Energy and Building Journal, the manufacturing phase or embodied energy consumption of a building can be about 10 to 20% of total energy consumption during the life cycle of a building, while the operation period can be accounted for 80 to 90% of total energy consumption, and the demolition phase can be accounted for 0.2 to 1% of total energy consumption. That's why when we say that the building is zero energy building, we can just focus on 8 to 90% of that 90% of total energy consumption. But also we have to have a glimpse on manufacturing phase or pre-construction phase of that building. So we have to reduce that energy consumption and also that greenhouse gas emission with using low embodied energy materials or system. This is a study that is conducted on a typical school building in Turkey. As you can see here, the end-use energy consumption of this building can be reduced to nearly zero energy level with the aid of renewable energy systems and also passive improvements. As you can see, this is end-use energy consumption. Indeed, this table is just produced to show you here, and it's not a scientific table because if we want to compare the result of energy consumption, we have to use the primary energy conversion factor because natural gas and also electricity are two different sources of the energy, and if we want to compare them, we need to use conversion factor, and the conversion factor is different through different countries. And for example, in Turkey, the conversion factor for the electricity is 2.36, and the conversion factor for natural gas is 1. But here, I'm showing you the end-use energy consumption. And as you can see, it is very close to zero. It's about, let's say, 5 kilowatt-hour per meter square in Istanbul case, while in Erzurum it's about 12 or 13 kilowatt-hour per meter square, and in Antalya it's about 15 kilowatt-hour per meter square. But when we look at the embodied energy consumption, we can see that all of these measures have higher embodied energy in comparison with the rest of the measures and also with the case building. So it's very important to look at these values and to focus on these values. Otherwise, our result can be useless, or we may see some diverse effect on our studies and during the after the application period. Also in Turkey, there are different climatic regions. So all of these climatic regions may require different actions and different approach and different, let's say, guidelines and so on. Because, for example, Istanbul is located in a humid, temperate, humid climate. It has different measures, different standards. It should have different standards and legislations, while Erzurum is located in a very cold climate. So the temperature difference, which is one important item between Erzurum and Istanbul, maybe sometimes more than 40 degrees centigrade. So it's too high, and we cannot apply the same measure in Erzurum, Istanbul, or in Antalya, and for example, in Diyarbakır or other region of Turkey. So it's very important to conduct a specific study for every region and also every city of Turkey. But the same thing is not applicable for most of, let's say, countries in Europe, because they are located in a cold climate. So it's very easy to conduct a similar study in most of the regions in Europe, but in Turkey it's very difficult, and also in some countries that have that has different climates, also it's very difficult, and it needs to have extensive studies to reach to the proper results. There are two approaches in building zero energy retrofit. The first approach is to just use the renewable energy sources and install it on the building. For example, we can use photovoltaic system or let's say thermal collector and so on, and just install it on the building. But it has a huge problem because it results in high number of units. We need to use excessive number of the renewable energy sources unit, like photovoltaic units. We need extra budget, and it's resulted in higher cost. And also depends on these excessive material usage, the embodied energy or pre-installation energy of the building is going to be high. But of course, the application time can be reduced, and it seems that's as simple to take and study. We need to just know which amount of the energy consumption is occurring in that building, and make a simple calculation, and then install it. Install the units. Of course, installation of those units are not easy, but in the second approach, first of all, we need to have a passive improvement. We need to reduce the energy consumption of the building with passive measures, like adding the insulation, proper insulation level, insulation material on, let's say, exterior wall, roof, and also ground floor of the building, changing the, let's say, glazing materials and so on, and then install the renewable energy system on that building. In that case, we need lower number of units, photovoltaic units, and it leads to lower cost and lower embodied energy, but the application period and the application time of this approach is higher in comparison with the previous one, and also advanced study is required here, because first of all, you have to study on the building. You may need to some simulations, some calculations, and then decide about different measure that maybe you need to choose a measure from 100 or 200 measures, and also you may need to thousands of simulations, and then decide about the proper measure and proper improvement measure, and then you need to apply it. You need to make change on your building, and then again you have to calculate the amount of the energy consumption after that improvement, and then decide about the number of let's say photovoltaic units, or the number of thermal connector units that is necessary to install and to meet the energy requirement of that building. But the second approach is more better than the first approach because of the cost, because of the number of the units, and because of the embodied energy, lower embodied energy consumption of that building. This is another study that we have conducted on one apartment building in Erzurum and Antalya, and is published in Energy and Building Journal. As you can see here, with just some simple improvement, we can reduce the energy consumption of an apartment building in a huge amount. For example, in Erzurum, it is possible to reduce the total energy consumption of the case building from about 165 kilowatt hour per meter square annually to about 106 kilowatt hour per meter square. It's about a third, 1/3 of total energy consumption. It is very huge amount, and these are just simple passive improvement. In these measures, we just add the let's say insulation layer. We just choose a proper insulation layer for opaque component and for glazing system, and change just the let's say glass of the windows and add the insulation layer. And also we can calculate the total cost of the measure with the aid of some standards. As you can see here, this axis is showing the global cost with dollar per meter square unit, as you can see here. And also in Antalya, this graphic is showing the amount of primary energy reduction and also global cost reduction with each measures. Of course, as you can see, some measures will lead to increase the total cost, but they are energy efficient. But we have to consider the total life of the building. Here, our focus was just on the, let's say, operation phase of the building. But as I said before, in the previous study, our focus was on the, let's say, whole life cycle of the building. And here you can see just passive improvement, and as persist on it, we can reduce the energy consumption through some passive measures in a high amount. If we want to categorize the challenges, we can see that there are some scientific challenges, social challenges, financial challenges, legal challenges, and also technical challenges. I'm going to focus on each of these challenges in the forthcoming slides. But if I want to explain shortly, I can say that scientific challenges are regarding to the let's say studies, are regarding to the different deficiency about data, about the different steps of the study. Social challenges are regarding to the awareness level, willingness of also of the owners and let's say users. Financial challenges are regarding to the economic and the budget that are required to conduct the let's say zero energy retrofit or to design the zero energy building. Legal side or legal challenges are regarding to the, let's say, legislations and also market barriers that prevent those legislations, those standards to be applied properly. In the technical side, we have problem on about know-how of the let's say manufacturer, the laborers, and so on. In the scientific side, there are lots of uncertainties regarding the future climate, regarding the economy, and regarding the input and output of our study. For example, we don't know what will happen in the future. Our studies are rely on previous climatic data. Most of our studies are relied on those data for about 20 or 30 years ago. So we know that climate change is a real fact. So what we have to do here, we need to have a proper prediction about the future data. But it is not easy. There are lots of different climatic models, different climatic predictions, but it is very difficult to know which of them will be happen in the future. So it is an uncertainty that affects the result of our study. Also, it's applicable for economy. We don't know what will happen in the future. We cannot estimate the exact amount of the, let's say, inflation rate or interest rate in the future, but our building will continue to stand up and also to continue to operate in the future. The things that we have created today will be stand up for, I don't know, 50 years or 60 years, and also continue to change, to impact on our environment and also to impact on our budget. So we have to have a proper estimation about the future economical factors. Also, we have uncertainties in input data. Of course, we can estimate some data, we can find some data from manufacturer or from, let's say, the operator, manager of the building. But all of those data are some estimations. And we cannot define that the building is going to operate in the same way for a long time. For example, if we estimate that within an apartment building, a family of 3 persons is going to live in the future, we don't know that. For example, during the lifetime, all of these 3 persons is going to live here, or if the unit is going to be sold, which kind of family is going to occupy in that unit. Also, the outputs are not so reliable because of the different uncertainties in the inputs, and also sometimes we have forgotten to use some data to enter some data, but we have some outputs from those analyzes, especially when we use the simulation software. Some templates can be used, but we may not be aware about it. So that's why there are uncertainties also in the outputs. Also, there are lots of parameters that we have to focus on it. For example, we have to take a study on the operational energy, on the embodied energy, on the greenhouse gas emission, embodied greenhouse gas emission, and also operational embodied gas emission, visual comfort, thermal comfort, health, investment amount, or the budget, global cost, payback periods, and so on. So it is very difficult to decide and take one measure or to apply on our building, and considering all of these parameters to be true and accurate in that measure. Also, another problem is the lack of public data, especially in Turkey. There are few information regarding the embodied energy consumption and embodied greenhouse gas emission of different materials. But in some countries, those data are public data and you can reach to those data easily. But here in Turkey, it is a problem, and it is an influential problem that should be solved and should be overcome. This is another study on other typical school building in Istanbul and Erzurum. As you can see here, it is published in Applied Energy Journal in this year. In this study, we have tried to focus on different criteria, different, let's say, items. But of course, I'm sure that we have forgotten to use some criteria because, as I said before, there are lots of different criteria: cost, energy, embodied energy, payback period, let's say, and so on. But in this study, we have tried to discuss these, let's say, criteria and expose and recommend an approach to use all of these criteria in our studies. And these are the result of our study. As you can see here, we have focused on the total cost, carbon emission of different, let's say, measures, payback period of different measures, and also the comfort level of different measures that we have chosen and applied in this primary school building. And then, after conducting such a study, we have decided which of these measures can be applied. But during our study, we have found that some measures that reduce the energy consumption and lead to the lower amount of the cost may lead to, let's say, increase the discomfort level in our building. So we have to have a balance between the different items to choose more applicable and better measure to be applied on our building. In the social side, we have a huge problem regarding the user awareness and occupant willingness, and we can overcome to these, let's say, challenges with different trainings and different educational, let's say, activities. But sometimes, if we evenly increase the awareness level of the occupants, they may be reluctant to involve to the, let's say, retrofit action, because sometimes, for example, elderly people are most of the time are reluctant to involve to such an action because of the disturbance level, because of the time of the application, and so on, and of course because of the budget. But we have to try to solve our challenges. If we increase the awareness level, maybe they try to find some budget, maybe they are, let's say, encouraged to involve to the retrofit action with their own budget. But we need to do it. We need to increase the awareness level. But also we have another problem, that is diversity of the users. Within an apartment building, there are lots of, living, lots of owners, occupants with different perception, different understanding, different view to the life. And it is very difficult, and also with different economic level, and it is very difficult to find a specific measure that can be applied to all of those units and can solve the problem of all of these units. But as I said before, we have to try. also the behavior of the occupant is very important because of the diversity between occupant. The behavior of the occupant also can be different. For example, some occupant may forget to, let's say, turn off the light when they are outside of the home or outside the office. If we have even, let's say, smart system, maybe they caused some fault because of misusing of that system. So it is very important to consider the occupant behavior and also try to train them to use the system. In the financial side, because of the high initial investment cost of, let's say, our retrofit action or our design action. Yeah. Is there any problem?
No. In fact, we have a little bit squeezed with time.
Okay.
Dr. Ashrafian. So this is
last 5 minutes.
Last 5 minutes.
Okay. I will try to increase the speed of my presentation. In the financial side, it is very important to find proper financial instruments like low interest credits, performance contract, or crowdfunding and similar innovative and attractive financial instrument to solve the financial problem, as I said before, due to the high initial investment cost. We are faced with huge financial problem. Also, the risk of the investment because of the economic uncertainties is too high. So it is the things that cause to reluctant for occupant, for owners to involve in the actions. In the legal side, we require different standards, different legislations to be applicable in different climatic regions, and the inspection mechanism should be drawn properly, should be created properly, and all of these standards need to be revised regularly because of the systems and because of the technology development. We need to also regularly revise these standards and update them. But most of the time, we may say that some standards remain for 10 or 20 years, and it is very, let's say, incorrect to have such a standard for a long period. Also in Turkey, for example, we have just a standard regarding to the insulation level, while we have to have extra standard regarding the total energy consumption, regarding the systems and so on. In the technical side, apart from the know-how of the labor and auditor, we are faced with high technology requirement and also difficulties in the inspection and monitoring mechanism. Also, we are faced with problems and barriers regarding the tools. For example, in this study, we have tried to model this building, but this is the output of our modeling. As you can see, it is different than this one. Of course, the result may be not very different, but we don't know. Maybe it can be different if the tool let us to model the exact things in the modeling process. But we guess that the result cannot be different, but it is also a limitation from our modeling. So we have to also try to find a proper model. Or in this study, we have just choose some, let's say, different glazing or different transparency ratio, but we couldn't model on just one let's say, tool, one simulation software. we need to use different simulation software to decide about the comfort, visual comfort, and also to decide about the energy consumption of this school building. So if we have one combined, let's say, simulation software that is advanced in all part of this, let's say, study and analysis, it could be very useful. Our recommendation to overcome all of these challenges is to find reliable data. This is, I think, my last slide. So I think I will be finished. I will finish in 2 or 3 minutes. The reliable data is very important, and we need to find reliable data. And it is my recommendation for Turkey to publish free and public data regarding the embodied energy and embodied carbon of different material. We need to increase the public awareness through different training, different podcast, TV broadcasting, and etc. Financial instrument like step-by-step application of retrofit action can be recommended in this step, and also the different obligation and standards are necessary to be published and to take in the force. And also we need to have some training for to increase the know-how of the laborers and workers in this, let's say, in this subject. As you can see here, during one study, we decide to have an extra process in decision making for, let's say, scenario choose and for measure application. If in this study we have decided to divide the proper measure to some let's say, steps, and this is the process that we take for decision, for taking decision about proper measure. And this is the process that we take to calculate the total cost, the total payback period, and total cost of our application. It is very difficult and it is very time consuming. But of course, with the aid of this study, we could reduce the initial investment cost and the amount that should be pay for the, let's say, retrofit action to a reasonable amount that may cause to encourage the owner to involve to the action with their own budget. And in this case, the financial system, the financial process can be more easy, and with the aid of just small credit or any other governmental encouragement, the owner can involve in the action easily. Okay, thank you very much. It's all for my presentation, and I'm sorry if I extend the, let's say, presentation time. Thank you very much.
Thank you, Mr. Ashrafian. Now I want to pass to our second speaker, Dr. Nuri Cihan Kayaçetin. Dr. Kayaçetin is graduated from Middle East Technical University, Department of Architecture in 2006. He received his master's degree in 2009 from the same university with his thesis on knowledge management in architectural offices, and he received his PhD in 2018 from the same university on environmental life cycle assessment of built environment. Since 2015, he has been coordinating international projects on energy efficiency in buildings in Turkey. His current expertise includes life cycle assessment of built environment and transportation and assessment of embodied and operational carbon, energy audits, and energy efficient retrofits of buildings, buildings typologies, and building stock analysis, and nearly zero energy buildings definition in Europe and Turkey. He was also giving lectures in Middle East Technical University on a life cycle assessment of the built environment. And now currently he is doing his postdoctorate studies on ecological and social renovations of buildings in Belgium, KU Leuven.
Yes.
Right, Dr. Kayaçetin?
Thank you, Fulya, for this
now.
Introduction, and I thank you for Touraj Bey for his comprehensive presentation. So I will also have a similar approach with the previous presentation, but I will keep it simple as the title of the session is an NZEP for everyone. So again, but I will have an approach from a life cycle assessment and the effects of this approach on how we solve the NZEP situation, and actually how LCA can justify a local architecture approach and with quantitative outputs. Let me just share the I hope you can. Okay. I believe you can see the presentation right now, but correct me if I'm wrong.
Yes, we can see it.
Okay. So, of course, the focus of this conference, and I thank to all the organizers for the chance for giving us present our studies and opinions on the NZEP definitions and approaches. So I will keep it simple for what is NZEP, because other experts have all clearly give the definitions. But what I want to focus is on, again, on the embodied carbon and energy of the buildings. So NZEP, of course, requires a high-performance building, but it focuses on the operation of the building and not the production of the materials used in the buildings. So the concept is also sometimes confuses people. So with one small letter N and Z means a near zero energy building, while you use with a capital, it means net zero energy building. But actually the question is, does it actually mean what it says? Meaning that you can see the NZ progression here. So until 2020, European countries were planning to create an NZEP building stock and start to create that, but it's also ambitious for Europe, and some of the deadlines have been extended with 1 or 2 years. And there is no actually a single approach for achieving NZEP, and this actually gives us leverage on to adapt it on a better definition, which may include the production or end life scenarios of a building. And of course, European Union directive actually suggests for local authorities to come up with their own local solutions. And you know, the main instruments that we have for NZEP is the directive in the European Council, and there are some certain recommendations, but as I said, not as specific one solution. So I will get back to the life cycle perspective and NZEP, how it actually focuses on the operational energy, but it actually should include embodied energy if the definition says net zero energy buildings, or if not, then it should actually be net zero operational energy buildings to give the exact meaning. So that's the actual problem that we are having with NZEP buildings when we consider the whole life cycle phases of our buildings. So we only consider it for heating and cooling for our needs, but actually there is more energy that is put to produce the bricks in your building or even the mechanical systems, heating systems of your buildings. So here the punchline is the embodied energy. So as Professor Ashrafian clearly explained the life cycle stages, I will not go through them, but what is important is that this is a circular process. So it doesn't need to end. The process of building construction doesn't need to end at a specific place. It can go over and over again, and you may use the materials for an extended lifetime, which would actually decrease its impact on the environment in the long term. And actually what we would need is, as you can see in this basic graph, in the previous decades, what you see in the black bars is the embodied energy, and the yellow one is the operational energy, let's say. And then in the previous decade, the ratio was different. Buildings were including less material, like less insulation materials or thin wall components, or a single glazed window. That's why the embodied energy was low, and the operational energy is naturally high because the materials wasn't acting as efficient as insulator as we have now. And right now, what we have with the new emerging energy efficient buildings is that we put more material into the building. Of course, this provides a better comfort in the building, also an lessened operational energy phase, as you can see. But you also see that there is an increase in the embodied energy. And this optimization of these two energy phases is very important for us. So again, the significance of embodied energy. I mean, this we can keep on talking on this, but what will be the solutions, or what is the problems that we face with this? So the current directives, regulations require the contractors, engineers to put more materials into the building, because the regulation tells you that your buildings should perform better. Of course, there are multiple ways to achieve a more efficient building, but the industry tends to use the more straightforward, the cheapest solutions. Of course, when we say cheapest, it depends on how the monetary value is evaluated. Let's take an example of insulation materials. So you can import the best insulation material from a country abroad. Doesn't matter in this current global industry. But when you do that, right now you don't actually pay for the environmental impacts of this material 100%. That's why actually some materials are cheaper, because they use probably hazardous materials which are not currently being penalized or taxed. But in time, if some of our audience may know about carbon taxing, so with materials with high carbon may become more expensive in time. So what is cheap right now may be more expensive because of this environmental perspective. So what does that bring to us is that we should use low carbon components for environment and for a better construction industry. What does then low carbon component mean? Actually, it means a bio-based material or lightweight material. Lightweight because it gives us a less mass of a material, so that it means you have less material. Bio-based materials are pretty new in Europe, there are certain research on that and it's being used, but in other regions it's pretty new, but they act very well in the concept of life cycle assessment. And of course, what it brings us, again, the use of local materials. I mean, in the global industry, we know that every country is now linked, but we need to take a step back, it seems. Because when we use the global industry in the full scale, we are missing some local opportunities. And of course, we keep on saying that the local architecture was very good. The old buildings look very nice, and actually they feel better. And there is actually some quantitative reason for that, and life cycle assessment can prove this. Because if we would be able to use local materials, then we would have less transportation, which means less carbon emissions from the transporting vehicle. Could be a ship, a train, or whatever, but it means less carbon emission or less energy. And the last, maybe but not least, the recycling of materials. This is very important. So right now in current Turkish construction industry, the demolished materials goes to waste or landfills, which is actually the worst case in the possible end of life scenarios. Some quite a ratio of building components can be reused, and this will not take additional energy to produce new materials. And this is actually a dilemma. I mean, we've been talking about increasing the efficiency of the buildings, which means that we are trying to decrease the operational energy, but to do that, we need to put more material, and that increases the embodied energy. So there should be an optimization of the two, because just imagine we apply 40 centimeter of insulation or 50 centimeter of insulation to all the buildings in Turkey. Just imagine the amount of, or necessary amount of production for this material. This would mean a sudden impact on the global warming with the carbon that we emit during the production. And then the question is, when do we need to mitigate carbon emissions? If we say we should do it now, then we cannot produce lots of materials. But then the question is, when do we need to mitigate it? It could be 30 years, 50 years, 100 years, but as Dr. Ashrafian said, 100 years is too late. So we need to have an optimized solution. I will skip this because these are already given, but we can say that the embodied energy in the buildings are on increase, and we should be careful about how much we increase it. And in recent research, we see that less insulated buildings has around 70 to 90% of operational emissions, which is actually the previous decade's information. So now in our current decade, the efficient buildings has almost 50-50 between embodied and operational emissions. And on top of that, insulation materials, of course, now increases their quantity in the buildings, so it increases the embodied emission. So in certain cases, only the insulation material can account up to 20% of all emissions. And then I will just brief my explanation with a graph of possibilities of building scenarios. We will have a building construction and 2 renovations in a 50 years of time, in a building's lifetime, let's say. So what you see is an standard building. You build it with a relatively low material. You don't put too much focus on the energy efficiency, and it lives for some 15 to 20 years, and you need to renovate it. You put some more materials, remove some materials, And then you see that between 25 and 40, the energy consumption actually decreased when compared to the previous 10 to 25 years, because you put in more material and probably better materials, and then it lived on 40 years, and then you do a second renovation, and then in 50 years the building life ends. But what if you do a better efficient building? So you, in the start, you put more material, maybe double material, but then the building both acts better and doesn't need maintenance like in a standard building. So you put in more material, but building acted properly without a second renovation, and then you see that the total emission ends up less than a standard building. But then what if I spend all my money on my building? I want the best one, but I just exaggerated it. Okay, I put I put everything that I can find to make it a zero building, let's say, or very nearly zero building. But then, as you can see, even if you increase the performance of your building, you might end up with an increased amount of emissions in overall when combined the embodied energy and operational energy. And this is what we don't want. We want to avoid this. So that's why we need to take care the production phase of a building and end of life phase of a building. So I'm finalizing my presentation. So there are many frameworks for an energy efficient or NZEP building. We all see that in the LEED, BREEAM, and now most are coming, but they have limitations, and for good reason, of course, because as in the presentation, we see that there is lack of data, lack of expertise in the construction field regarding the environmental data of building components. But we need to have a comprehensive perspective. We have to have it, because I'm sure some of our audience remembers the ozone crisis that was there around 90s. But then as globally the problem was fought and it was reduced, but have we forgotten about it? I don't think so, because ozone depletion is an impact category in life cycle assessment, as well as water, as well as acidification of land, which prevents agriculture. And these needs to be taken into consideration, as well as energy and carbon and global warming, so that we will be ready for the next fifth error or sixth error, whichever it will be. But then, as a final sentence, I can say that life cycle assessment, when we take into account the recent studies, justifies the use of local architecture and local components. So we can use this quantitative approach of life cycle assessment to justify what was already being said for years. So I find this very valuable. And I thank you for your time and this opportunity that you give me for this presentation. Thank you.
Thank you, Dr. Kayaçetin. I think we have time left for questions and further discussions. We have like 20 minutes more. Yeah, we have. By the way, as you mentioned, Dr. Kayaçetin, our subject is zero energy buildings for everyone. So I want to be the ambassador, everyone as the ordinary people outside. So this is a question for both of you, in fact. These zero energy buildings, how are they going to affect the life of ordinary people? What should they expect? And do you think, I think we are all around the same generation. So my first question, is it going to touch our lives, or is it going to touch the lives of our kids or our grandkids? So just to hear your estimations on that. how do you see the future and the evolvements? I'm not asking about this 2050 or 2030. This is all signed, I know, but what will be the real life?
I can take some rest. Actually, maybe Touraj, Dr. Touraj may want to answer first, and then I can join. However you like.
Not a matter. It's not a matter. Indeed, if we can create our building according to the zero energy approach, this one will affect the humanity, not just our life and not just the next generation life, but also the whole humanity will be affected. Because of the climate change, because we will reduce the effect of, let's say, our environment, our building on the climate, and it will affect our life and the whole people. I mean, the humanity will be affected. If we mitigate the, let's say, our impact on our environment through reduction of the energy consumption, through reduction of the greenhouse gas emission, the climate change and the global warming will be diminished, and it's the things that will be will touch our life and will touch the life of whole people in the world.
So it will start right now. That's what I hear from you, Dr. Touraj.
Yeah. If we wait for some years later, we will be so late. It will be so late. So we have to start from today and not wait to the, let's say, some years later, and don't think that this is, for example, we have 20 years or let's say some years to finish. Indeed, we have to start today. It is very crucial. It is very important. Because if we extend, if we continue to impact on our environment, the impact of the environment on our life will be twice, thrice, and so on, sometimes extra than our impact on the environment. So after industrial period, indeed, if we make a ratio between the Earth's, let's say, age and the period between industrialization starting date and today, we may see that this period between after industrialization period is a very small portion and negligible portion of the Earth's age and Earth's lifetime. But during this period, the impact on our environment in such a way that global warming, climate change, and so on are affected our life. So we are very influential. So our activities are very influential. That's why I've said that we have to start from today. If we wait to some years later, and if we continue to impact on our environment, maybe it will be too late and we cannot compensate our impact on the environment after some years and some months even.
Thank you.
I can also add, I mean, I also totally agree. I mean, the focus currently for NZEP is the global warming, of course, because this is the most immediate problem that we are having. But also we can have a look into our lives and what it could really change for the daily life. I mean, and NZEP doesn't only deals with the energy consumption, but it also the approach itself for a better performing building increases the comfort of the residents or the indoor air quality in the building. So if we look from a pragmatic approach for ourselves, then we actually benefit a lot of it, because there are lots of health problems that we are having as we are living inside the buildings. This would also be decreased by better buildings. And for example, we also had a study on a school in Kırıkkale, and we see that the ventilation and the carbon dioxide level in classrooms is actually a very critical problem. And just imagine the function of a school building is for students to learn. And you can also imagine in a classroom without fresh air, it's very easy to fall asleep. So actually the students cannot perform the function of the building, which is learning, in a standard or a less performance-based building. So with NZEPs, this will also be provided, and the people will live in better conditions. I think that's also accounts when we talk about NZEP.
I can also add some other item regarding this question. Also, let's say, widespread use of the zero energy building will affect and reduce the dependency of the economy, because in that case, for example, in Turkey case, because of the high import of the energy from other countries, indeed, the country has a dependency to the other countries. If we reduce the amount of energy consumption, it will also reduce the dependency of the country. And also there are some other indirect effect of, let's say, zero or low energy consumption, like decreasing the unemployment rate, because we can direct the budget to the other phase of the economy, and it is also another indirect effect of the zero energy building construction. So if we focus on different part of this sector, we can find lots of other benefits regarding to widespread use of zero energy building in our society.
Thank you very much. That was very clear from your perspective. Mr. Kayaçetin, my next question is for you. How could anyone improve building components from a life cycle perspective for their production or end-of-life phases?
Okay, I mean, that's a relevant question because the methodology of life cycle assessment is actually a comprehensive analysis method, and this is relevant for users, producers, because it gives you the chance to see the problems related to your material production or how you make use of the waste during production. So only when you can see the problems, then you can improve your own material. And so in European and in global market, now there are some labeling processes which we call the environmental product declaration of any product. So the producers actually declare the environmental impact of their products. So also in Turkey, certain companies are seeking after these labels in order to increase the value of their products. So that's actually how the building components can be improved in a global or in a Turkish construction industry context. But maybe the basic approach would be decreasing the hazardous materials in the components and the use of heat. And this is very important. If there is, for example, glass or aluminium, I mean, aluminium has either special condition, but with the use of, let's say, a glass component, you make use of huge amounts of energy while producing it. So either you will find ways to use less energy to produce the same component with a glass, or you decrease the amount of glass to have a better environmental performing component. Or with a lightweight material. I mean, in Turkey, you can use and we'll say in Turkish, saman balyası for insulating your houses. We have kerpiç in our local architecture, but you can use it differently as an insulation material. So there are multiple ways of improving. And but research and development efforts are necessary for that, of course.
Thank you very much. I think we have some more time. So my next question is for Dr. Ashrafian. Can you please explain us the challenges regarding zero energy buildings in the education sector and architecture design studios, please?
Yeah. Indeed, we can say the same challenges in the education environment. For example, in my presentation, I have persisted on the, let's say, financial challenges. Indeed, students also think that when we want to design such a building, we need to use extra money, we need to spend extra money. So why we have to do it? Also, the environment, the awareness level is very important. If we increase the awareness level of the society, the students' awareness level also will be increased, and therefore they will find that, yeah, we are going to spend much more money, but there are lots of huge benefits regarding to, let's say, widespread usage of this kind of building, I mean zero energy building. So yes, we have to try it. But currently, due to the, let's say, awareness level, I cannot say just awareness level, but there are lots of different challenges that cause to reluctance among students to use such a measures, such let's say actions in their own design. And also the thing that is very important is because of the uncertainty. Since students like to design a building, at the same time it is very difficult to decide about the pros and cons of the, let's say, those measures. For example, if they decide to apply let's say a high insulation level in their design, they have to know what is the impact, what is the result of that excessive material usage. Or when they want to use a photovoltaic system, they should be able to calculate that, let's say, that impact and the system on the total energy consumption. But in just one design studio in one semester, it is very difficult to put all of those items and let's say work and study on those, on all of those items. So it is very challenging in architectural design to use and to teach about the zero energy building.
I think we have some small time to have one more question, and that can be for both, but let's start with Dr. Kayaçetin. What would be the next problem we can face, like what we are having now with global warming? What is your estimation?
As I mentioned in my presentation, actually, this is a very critical point, because now we are focusing on global warming. Are we missing some other problems? So I would say it's the water scarcity. And actually this is also related to global warming, because now the seasons are changing, the rain regimes are changing. We are already feeling it in Turkey. Some countries may not feel it at the moment instantly, but we know that it is coming. So with the same approach where we talk about NZEBs for energy, now there are emerging concepts for zero water buildings. They are also coming. So we also need to see if we can decrease the amount of water we use and decrease the amount of water is being used for building materials, because water is also a very critical production element, which actually you don't put the water into the material, but you use it for some other means to decrease the heat during the process and whatnot. But water is very valuable. Maybe it wasn't before, but now the value of water will increase, and probably we will be dealing with this problem in the near future. That's my opinion.
Dr. Ashrafian, any comments on this subject from you?
I think also we are going to face with huge social problem also, because of the, as I said before in the previous question, because of the dependency of our countries to energy import. If we continue to use extra energy, if we continue to consume extra energy due to the economical problem, also we may face with social problems, social, let's say, barriers as well. So it is very important to try to solve our problems and try to reduce the total energy consumption. But of course, the climate change, the scientists that are working on climate change can answer better than me about this question, because it is really scientific question. But to my mind, apart from the items that Dr. Kayaçetin influence on it, I can say that the social problem in the near future also is going to be increased. And we have to find some way to overcome to those problems.
You are totally right. It is going to be a combination of two, probably, and we will not know which comes from which one. So thank you. I would like to thank you a lot for these valuable speeches and your presentations. I believe everyone learned, not only the professionals of our industry, but everyone learned some from these presentations. I would like to thank also the organizers of these sessions. It is very important and very valuable for the Earth and for our country. So I hope such organizations continue, and I want to wish everyone a good day and a healthy upcoming days.
Fulya, thank you. But I think there is a question, but I'm not sure if we have time.
I think we are finished with time.
Okay.
Okay, because we are just finished our 90 minutes.
All right.
And this is our 2 minutes.
Okay. Okay.
Thank you, and hope to see you in some time.
Thank you very much. It was nice to see you. Bye.
Bless you guys. Thank you.